Hello everyone, welcome to day 15 already of our journey of becoming a software developer. This following video you're about to watch, I'm solving an easy problem, but the acceptance rate is a little low. So let's see what happened in the video. If you like the video, if you want to follow and support my journey, please like and subscribe. I'll really appreciate it. I'll see you inside.
All right, and welcome everybody. My name is Enrique Barkley, and this is day 15 of our problem solving videos for YouTube. In today's problem, I'm picking up the problem of today from this list right here on LeetCode. I think I'm gonna stick to this one finally. I've been switching over NeetCode's .io roadmap. I've been doing arrays and hashing. I've been doing grind. This is originally blind 75 plus grind 75. This tool right here where you calculate how many weeks you have left before you start getting ready for interviews. As long as you feel ready, right? But also I found this list on LeetCode, and since it's sorted by their data, they get all these people getting to select the questions that they've seen in interviews before and all that. So I figured it would be a good list to do it. So the problem of today is I'm just gonna start from the top. We're doing arrays and strings. I'm glad it's an easy question. I'm not feeling a medium today. But I attempted this, and I decided to, instead of trying to understand everything and then try to explain it, I was like, let's just go ahead and do it live. For me, works that if I speak out loud while I'm thinking, I don't let my brain do all the work. I help my brain kind of remembering things. I don't know what's the case for you. That works for me. If I just sit there, stare at the computer, trying to find a solution, doesn't gonna work. So the problem is merge sorted array. I'm gonna go ahead and do a quick read of the problem. You can skip this part if you'd like. I'll leave all the timestamps down in the description. But the problem reads following. You're given two integers, arrays nums1 and nums2, sorted in non-decreasing order, and two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order, which is just increasing order or incrementing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has length of n. Okay, I think they said that here too. But anyways, so m plus n is going to be the length of nums1 here, which in this first example here we have 1, 2, 3, 0, 0, 0. Should be ignored. Okay, since 0 should be ignored. And then m and 6, this is length 6. And then 2, 5, 6 are the numbers we should merge here. As we can see in the output, we have 1, 2, 2, 3, 5, 6. So these three spaces here marked as 0, we can just look at them and see like they're empty. And we would have to insert these numbers here. What happened is that as we can see here, 2 is going to be less than 3, and the output list has to be sorted. So we have to think about that. Here in the other example, we can see that, let's see, n, it's equal to 0, so n could be equal to 0 at some point, and I assume, yep, m could be equal to 0 at some point too. The constraints of the problem is that the length of the first array, input array, is going to be the total of the integers m plus n. And then the length of the second array is going to be equal to n. That makes sense. 0 is going to be less or equal to m. Less or equal. Okay, so m. Okay, yeah, we saw m could be equal to 0. And then n is going to be less or equal to 200. We saw that n could be equal to 0 here too. So 1 is less or equal to m plus n less equal to 200. Okay, so m plus n, there's always going to be at least one number. So basically it's just saying that m and n would have at least one number at some point. They're both not going to be equal to 0 at the same time. That's what I'm thinking. And then the numbers inside the arrays are going to be anywhere from 10 to the power of 9. So basically 32-bit integers. So, large numbers. And then it says, can you come up with an algorithm that runs in m plus n time? Even though it's an easy question, we can see the companies here that asked that question, allegedly. It has a low acceptance rate. For being an easy question. So we can see how people get tripped here a lot. That will probably be me a couple times today, but anyways. There's an easy way to solve this if they wouldn't be asking for these specific runtime or time complexity. But it would be, I believe it would be equal to n log n. Because we have to use the sort method in Python, and that's, I believe, teamsort or something, which is n log n. But the way to do this would be, so m and n here are basically pointers, if you will, or parameters, in the sense of we can use them. We know that m are the numbers we're gonna need to merge, as it says here. The elements that should be merged, right? So this is gonna tell us how many elements are going to be in here, are gonna need to be in here. Now, this is the length of this right here, but so far we can tell that besides both arrays being sorted already, it's saying that the last n elements are set to 0. So we know that, for instance, these are the numbers we're going to need to merge, which is going to be these numbers, and these are the numbers that are going to be equal to 0 in this other array here. So without the follow-up questions, without thinking about time complexity, which is never the case, but just so you know, there's a one-liner we can solve this in a n log n time complexity. Performance always matters, I know, but in case it doesn't, we could just say it's asking for nums of 1 not being returned, and also like being the data structure that gets modified, right? So basically in place, we have to modify nums of 1 in place, and for that to happen, we could just say, nums of 1, we need to sort. So we can say nums of 1 from the beginning. We're just going to slice the list and say that that's going to be equal. And here's where the complexity happen. We can just sort nums of 1. We know that these numbers up here, up to m, always up to m, are going to be filled, because this is the amount of numbers we need to merge. So we can say nums of 1 from the starting to from m, from m, which is going to be equal to this number, plus nums 2. That way we don't even need to use n there, because what we're saying is, sort whatever you grab from this n of the input array, the first array, and add it to this array. You know, and it's all happening from the beginning to an end, if not in nums of 1. And we're gonna get like a weird result at first, but then the sorted function will work it out. And that would work if time complexity. Oh, what am I doing wrong here? I was so confident. Oh, okay, yeah. Nums of 1 fermented equals sorted up to from the beginning up to. Oh, okay, this is backwards. Yeah, because I want to grab all the numbers from the beginning. I was starting from here. I need to start from here because these numbers are part of the array. And again, that should work. Yes, there it is. So yeah, as we can see, what is another test case? Maybe 3. Oh, okay, equal to 0. Yeah, I can submit that, but that's not gonna be part of the. That's gonna overwrite this right here. It's not gonna count, and I don't want to submit that because I know that's definitely not what they're asking for. But anyways, that we can solve that problem with that with that code right there. But that's not what they're asking for. Okay, so we're gonna have to go deep and do it m times n, which just means we're gonna have to iterate over. It's gonna be big O of n plus whatever the length of the second array is. Okay, so it's gonna be big O of n plus n. So I want to say linear time, but I would say a little worse than linear time. So, but okay, let's go ahead and do it. So the first thing we're noticing is that the m is going to be the numbers we need to merge, and n is going to be the numbers that are going to represent the length of nums2. We saw here that at some point we're gonna have at least one number in one of them, so they can't be 0. Okay, so they can't be 0, and also okay, I guess we could pull this bad boy here. Always ready to swap the whiteboard. But anyways, we could have the array. Every time I connect this thing, it switches. Anyways, we can have. I guess I'll turn this way. Perfect. So we could have these. All right. What is going on here? Try to use the little device here to do the array, but I guess I'll be more careful. Anyways, that's going to be nums of 1, or nums 1. And then we're also going to have nums 2. Nums 2. The 64 bits, 32 bits. Bad joke. Let me see. So we're gonna have, let's see. We said 1. Nope. We said 2. Nope. What is the example we have? 1, 2, and 3, and 2, 5, and 6. Okay. 1, 2, and 3, and 2, 5, and 6. Three, and then everything else is zeros back here. And then we have 2, 5, and 6, I think. 5 and 6. Okay. We didn't need to do that so big. Anyways, looks a little better. So we know we have m and we also have n. In this case, the m is equal 3 and n is equal 3. And the size of nums1 is going to be equal to m plus n. These are the numbers that are going to be merged in here. So we can use this. What basically this is saying is we can use this as a counter. This one too. We can use both of them as a counter. And we can basically say the nums of 1 has to be modified in place. So we could say these are pointers that I'm pulling out, and I'm trying to see how to manipulate them. But we can, if I start the pointers, let's say we start pointers at the beginning and compare them and say, you know, is nums of 1 at that index less than this number? Yes. Okay. Continue. Is this number less or equal to this number? In this case, yes, is equal. So we move to the next thought. Is this number less or equal? No. So if it's not less or equal, we will swap them, right? We would send 2 over here, and we would send 3 over here. We're basically using both arrays to like interchange information between themselves at the same time that we iterate over the array with pointers that are going through the same index. And since m plus n, it's going to be equal the length of this array, then we can basically set this pointer to run m plus n times, which is I think that's where the complexity comes from. Okay, and if that's the case, then we're just gonna go down the road or go down the first array, and you know, is this number less or equal? Yes, it is. So we swap this number back up here, and this is just trying. Okay, is this number less or equal? It is. So we swap it, and as we can see, we're gonna end up with the sorted array we need by basically iterating over both at the same time. So what I'm saying is here, let's go back, right, and see if I'm starting here. So I know that could be a possibility, right? Now, what is the condition I'm trying to look for here? I'm trying to see if nums of 1 at that particular index, and let's call these index I, and let's call these index J. These are my pointers. Let's just go ahead and kind of group them here so I don't have to move them at different times. Anyways, so this is my pointer I, and I'm going to say, is the pointer I less or equal than J? What did I just do? Oh boy, I think I just closed the whole thing. And I'm opening expansion. Jesus Christ, what am I doing? Not Xcode, Excalibur. Oh, here it is. Just, you know, computer things. Fat fingers. What's it called? Okay, we're here. And we're saying if the pointer if the pointer I it's less or equal to the nums 2, to this pointer, to the pointer J, let's just call it pointer J. If it's less or equal, then go ahead and move your pointer I to the same point. If if it's not less or equal, here it's less or equal, so we move to the same spot, less or equal. Okay, less or equal, then it would move here because it's less or equal. Oh, okay, I see a problem. I missed something. This two, I was like, wait a second, this changed the whole thing. And you guys probably saw it and didn't say anything. Anyways, so where are we at? We have 1, 2, 3, 2, 5, 6. Okay. So is this less or equal? Yes, it is less or equal, since what I'm trying to say is we have to traverse this array in a sorted order. And that's what I'm saying, the condition less or equal, because I'm trying to, since I'm starting from the beginning of the array, since I'm starting from this end of the array, everything obviously towards the left of this array has to be less, right? Because they want us to have this array, which is the output, in non-decreasing order or incrementing order, right? So if I'm iterating this way, everything on this side of the array, it's going to be less than everything towards the end of the array. So that's the reason why I'm trying to say less or equal, because what I want is to keep every number. I'm trying to minimize the amount of operations. So the reason I'm saying is the number at our original array less or equal than this array, then it doesn't need to be changed. So let's go ahead and move this pointer here to the next one. Is this less or equal? It is equal. So what do we do? Well, I would say it doesn't matter if we swap it. So we can continue if it's less or equal. So I know that saying equal is not going to matter for this case. So let's just say it's less, okay? And we're just going through options right now. So it's less or equal. So it's equal. So it's not less. So if I say is it less? No, it's not less. It's equal. So it's going to go to here. Is this less or equal? It is not. So once we hit a number that is not, then we swap it. That could be an option. So up to this point, all the numbers are less. Up to this point, the number is less. To this point is equal, but if I say is it less? No. So it's going to move in so it's not less. So I might swap it, okay? Is this greater? No. Is this greater? Is this greater? Huh. I think I hit a wall here because I'm trying to say if it's less than this pointer, swap it. If it's less, no, if it's less than this pointer, continue. If it's less than this, continue. Is this less? No, it's not less, it's greater. So swap it. Okay, so if the number 1 is greater than this number is what I want to say, okay? And that would help. Is the number at this index greater? No. Is it greater? No. Is it greater? Yes. If my pointer I is greater, then I'll swap the numbers. I can swap these numbers, I believe. And I'm just going to use this as a way to store my numbers. The problem is that this might change the complexity. If I do it like that, it might change the complexity because I'm gonna have to pass all the number here. So okay, no, I'm doing one swap and then pass it. Is this greater? It is not. So if it's not here, no greater, no greater, no greater. So if it's not greater, okay, the condition changed. So here the number was greater and that's what I swapped it. But what happened is, check these out. This is cool actually. Here I reached the point of m, right? Because m is equal to 3. So here I reached the point of m. And everything I have left here can literally just go here. just like that. So once I reach the length of m, if I decrement m, because as I said, we can use m as a counter. If I decrement that, then I can definitely just go ahead and say let's make I would have to have another pointer, I believe. Or I could just say instead of having another pointer, I could always say m plus n minus, you know, because m plus n is going to be the total of this list. So for instance, starting this pointer, m plus n is going to be here, right? Because that's the end of the list. It's going to be equal to 6. And if I go down, can I just start from here? Since it's sorted, this is always going to be the greatest element. All I have to do is compare. I could definitely start from the end. This is I think that's going to be a better solution. If I start from the end of nums2 and I insert that to in the position of m plus n and decrease m or n depending of where I'm at this pointer, because if I'm all the way here, m is done because that's the amount of numbers we need to merge, right? So okay. I could just say this. I could just say compare these two, m minus 1 and m minus 1. I guess I could try to think here. I guess I could say, because this is giving me the location of, or this is giving me the size of the array. But again, these are counters we could use. So if I decrease one of these counters, that pointer is going to change its position by every moment I decrease the counter. Now, what I'm trying to think is what condition I'm going to use to decrease this counter, because if I start this from here and I say, is this number greater or is this number less than this, I would go this way, passing every number from here to up here. Again, I have an issue here because this is how this array goes. It's 2, 5, 6. I don't switch that back. But anyways, if I say, is this number from here greater than this number, I guess I could start at the end here too. Wait a second. I could say m, if I start this pointer here and this pointer here, if I start pointer I, which is just going to be position m, because this is the number of items I need to merge, everything from here up, and I say, is the number here less or equal than this number? Less or equal? No. If it's not, go ahead and add it at the end, right? So it would substitute that, and I would move the pointer to here, and then I would decrement m, right? So now it goes here. I compare them to, which this goes here. I compare these two. The reason I'm comparing these two is because I'm trying to sort the numbers that are here. At this moment, because here 2 is going to be two is going to be greater. When 1's here, 2 is going to be greater than 1. But I know it's not going to be greater than 3 because it's sorted. So I could say just add it to this. I think starting from the end is a good idea. Like adding numbers towards the end. The problem is when they connect, because these number by that order, by the time j is here, this would be here, unless I do +1 and never change the first number. No, because what happens if then I get like 1, 2, 3 here, or like 4, 5, 6 here and 1, 2, 3 here? I have to find a way to go down this way, this path. Let's see something here. I just wanna see if I can see it in code, you know? If I can see it in code, maybe I can start thinking about other stuff. I know some people are better like at doing it on paper and stuff. I can't think about the code if I don't see it, which might be a problem. But anyways, well, the first condition we know is that m and n have to be greater than 0. If m or n are not greater than 0 at some point, then we just return either or, right? And I say either or because we either return m as the merge if m is 0, and we return m as the merge if n is 0. So while m is greater than 0 and also n is greater than 0, so while they're both and integers, positive numbers, I want to say if nums at 1 if nums at 1 at m, which is going to be, right, our third in our example is going to be the number we want to merge -1, right? Let's just do it like this. If that number is, so if it's greater, we said, if it's greater than the number at nums2 greater or equal nums2 and -1. So do I want to say if that number is greater if it's greater, add it, because I want to add it to the n. Okay, yeah, if it's greater than, So I'm starting from the end of both arrays. So what I'm saying is, and let me pull all this back here. I know this is kind of like the boring part, but also like it really helps. So I'm saying if this number is greater than this number, go ahead and add it at the end of the nums of 1. That's what I want to say, right? If it's greater, because we know it's sorted, go ahead and add it. So nums of 1 at what is the n, m plus n, because we know that that's the total length of the list. As long as so we know they're greater than 0, and I have to now decrease their order, so that pointer keeps moving. So numbers at the end is going to be equal to nums of 2. Wait, I'm missing something here. Nums of 2 minus 1. That number, right? That last number we just saw right here. So I just go ahead and did that. Now I say let's see. Now I say, okay, I'm thinking about if I decrease the counter now, or what else do I need to do, because I'm at the point where that's what I have. So should I go and say, decrease n or m, because I want to go down this way and compare with this guy, right? Go ahead and substitute m plus n minus 1. So should I decrease m? So I could say m minus equal 1. So that pointer moves. And nums of 1. Okay, so what? N minus 1. Okay. Okay, I think I have mems. Oh, okay, I see where the confusion is happening. If this number is greater than this number, I don't want to make this number go to the end. I want this number at 1 go to the end, right? Because what I'm asking if it is greater. So what I'm saying is, it's this number right here. See how I swap it? I wasn't supposed to swap it there. That's what was throwing me off. But I'm saying, is right. That's what I'm saying. Is the number at n minus 1 greater than the number at nums minus 2? So if it's greater, if the number here is greater, I need to send this number back here, but in my example is not greater. So let's see. I'm saying greater. So if it's not greater, if it's not greater, don't swap it, just go ahead and make that number. So nums of 1 at m plus n, which is the last index, equal to nums 2, meaning nums 2 is the greatest one, right? At m minus 1. Ooh, here what I'm saying is nums 1 at n minus 1, and then nums 2 at n minus 1. Remember we're using the M and N as counters, but pointers at the same time, which is tricky. M and M, not the candy, but M and M, or M and M, are both pointers and counters, because as we decrease M, we're going to first exit out of the while loop, which is going to give us the condition we need. And also we move down this line right here. So the next thing we're saying is so in this case here, okay, so if nums is greater, then I could decrease n, because I want to go down. So okay, if n is, if nums of 1 is greater than this number, which is not our case, okay, it's, I think I'm gonna have to grab another example, but what I'm saying is, and that's what I love to see the code. If it's greater, then swap it. If the numbers here is greater, then send it to the end, because what I want is to sort this list at the same time if I check as the same time I check both numbers. But if this number happens to be greater, go ahead and send it here. So what I'm saying is just whichever number is greater, send it to the back. And if it comes from M, from nums of 1, which is going to be our counter and pointer for M right here, that's how those two are related. Counter and pointer of nums of 1, counter and pointer of nums of 2. So if I decrease n minus 1, then I go to the next item right here. So n minus equal 1. Okay. And then that should switch all of them in sorter order. But what happen is, if I could say if m's greater than 0, okay, so if I get out of the loop and n is greater than 0, so let's say, okay, if we go through all the elements in M, meaning we still have elements in 0 and n, because we didn't decrease n all the way down. So if we go through this condition before we go through this condition, we need to, that means all the elements in n, are less, if they're greater, and I believe this is going to be n plus n minus 1, because it's obviously it's Python, not inclusive. Okay, so that's gonna be I think it's gonna look better if I just do it like this. I don't know, whatever's more Pythonic, you figure. Probably this. Who knows? Anyways, n plus, so if I go through this condition first and I don't decrease n, that means that all the nums at index 1 from the start point, that just means, what I'm saying is, like, all the numbers in nums of 1, so all the numbers in this list were all greater than nums of 2. Okay, and I don't have an example probably here. Let's see if I can find one, because that would be better for our test case. No, I don't have it. These are just the 1, 2, 3. But anyways, if all the numbers at here were greater, so if all these numbers here were greater, then that means all the numbers here, they all went to the back, right? If they were greater, they organize this way. So now I have to swap all the numbers from the beginning up to n, because n's not equal to 0. N might be equal to 0 at this point, but from the beginning of that array, so I need to swap all the numbers that are at the beginning of this array, okay, with the numbers that are at the beginning of nums of 2, or nums2 at that index all the way up to n. Okay, so what I'm saying is, if all the numbers, while the m and n are not 0, go ahead and check if the numbers at our first array are greater than the number of our second array. If they are greater, then go ahead and send this number, this particular number, to the end of our array, which is what I'm saying here. I don't know why that looks so bad there. I guess it's like that. And when I mean it looks bad, it's like not Pythonic, I guess. I don't know, it looks out of place. Might be wrong, but so go ahead and send this number to the end of our array, and see here how this is acting as a pointer, but also as a counter here. That's what I was trying to point out earlier. So if that's the case, then go ahead and swap them and decrease m. So we're done with the first array. Now, if that happens, if that's not the case, so if the number is not greater, then that means the number at the end should be equal to nums. This numbers, then it's gonna be the opposite of that condition. So that's the number that should be to the end of the array, right? And then we decrease n. But if we go through the whole first list and all the numbers are greater, that just means our numbers at n are less. So they should go to the beginning of nums1, and that's what I'm saying here. I'm slicing nums1 and saying, all the numbers from the beginning, I grab all the numbers from the beginning up to this point, n point, which is the numbers we have left here, and swap them with all the numbers from this list from the beginning all the way up to n, whatever n is. And I think that's it. Let's go ahead and run it. I think we're up to something here. Okay, we got all the test cases. Now, there's something here I'm probably missing, and it's I don't have, and it's for this case. What happened when they're equal? So that's what I was saying earlier. If they're greater or equal, because in this case they're going to be equal. So what's the condition there? So, but we could just say that if they're equal, it doesn't matter which one we grab, right? So let's just say if they're greater or equal, go ahead and swap them, because it doesn't matter at the end if it's in the same array, right? If it's in nums, it's sorted. So that takes a lot of out of our play. It's not going to be from n, and if it is from n, then we swap it. But it's not going to be, assuming it's not going to be, because n would have elements left. Okay, so let's just see what we got. Say blind maximally learn to track your progress and focus on daily questions. Wow, that's pretty cool. Wow, look at that solution we got. 100%. What is that? They're just butting me up. That's just a little butter there for me to start this thing. How much is it gonna be? Let's say I'm gonna start. Oh, nothing yet. Anyways, wow. Analyze complexity. n plus n, n plus n, and we completed the I'm impressed on like 100%. What is that? 83.80. Oh, okay. Gotcha. Don't feel special. It's literally you have three groups: the ones that use 1.47, the ones that use 1.28, and the ones that use 0. So that just means, it just depends how many people are using their server right now, or that particular segment of the server. But anyways, yeah, that was fun. I don't think I can see now why it has such a low acceptance rate. It's an easy question, but it took me like a long time. I went through a long process. I normally go through a long process here trying to explain this, also understanding myself and explain it at the same time. In an interview setting, I would do that less. Obviously, I would have less time, and I would just use this little notepad here, and just do a bunch of comments here, right? But the truth is that for the learning process we're on, it's good to speak the problems out loud, and that really helps. But anyway, so let's get some confetti before we go. Okay, we got the birthday. We need confetti. Confetti. Oh, I guess. Confetti? What happened with the confetti? We need confetti. Come on. Where are we getting the birthday? We're getting the birthday with celebrations. Not my birthday. If it's your birthday, happy birthday. We just solve a problem for you. Subscribe to the channel. It helps me a lot. Like the video. It also helps the algorithm, or the whole thing that you already know. If you really support my journey by subscribing or liking the videos, I promise to keep bringing value. If you want anything, if you want me to explain anything, if you want me to learn something, feel free to let me know in the comments. And also, check my links. And thanks again. Thanks a lot. Appreciate it.